Good morning, everybody, and welcome to today's event. It's Simon Hunter, and I'm going to be your host today. So let me start by thanking our sponsors, M2M Connectivity, Sierra Wireless, and the ARC Group for making this webinar possible. As a Sierra Wireless company, M2M provide IoT expertise and technology that helps power industries, improve lives, and paves the way for the next generation of wireless innovation. ARC Group, formerly known as Melbourne IT, is a leading digital professional services company with deep expertise in mobile, data and analytics, and cloud. ARC is also one of Australia's most awarded AWS premium consulting partners. So today we're going to be shining a light on digital twin technology. We're also going to be introducing you to M2M and ARC's new partnership. ARC and M2M are now working together to deliver digital twin technology in Australia. And they're utilizing ARC's consultancy services and expertise at delivering digital solutions, combined with M2M's expertise in IT network design, devices, and connectivity. We're going to be looking at how digital twin technology can accelerate manufacturing efficiency to help your business move closer to being disruption-proof. To do that, we're going to be talking to two experts, Benoit Tournier from Sierra Wireless, who's based in Paris, and also James Litchins from the ARC Group, who is based in Melbourne. Our agenda is split into three parts. Firstly, we're going to be looking at trends and talking specifically about digital twins and how we integrate them into the physical world. Secondly, we'll be taking an in-depth look at the Sierra Wireless Octave all-in-one IoT solution. And finally, I'm going to bring our experts back to the stage to answer your questions. We want this to be an interactive session, so I'd encourage you to ask questions as we go. And if you look to the right, you'll see a couple of tabs. One says questions. Please send through your questions using the questions tab. We'll also be running a number of surveys throughout the webinar, and they will pop up as we go. So to start our conversation about manufacturing and digital twins, I'd like to invite James Litchins from the ARC Group to join the stage.
Fantastic. Thanks, Simon. Okay. So manufacturing lines, they're noisy, chaotic, and challenging environments, from the vibrations to the sound levels to the electronic interference in the air. In fact, let's start by talking about air. It keeps us alive, and the compressed form is also a staple in majority of manufacturing lines and operations. The humble air compressor. Okay, maybe a little bit bigger and maybe a little bit more rumble instead of humble. In the old days, there was the physical air compressor. It's standalone and disconnected, requiring on-site expertise to monitor, maintain, and operate, with historic business models that were based on outright purchase or hire of the physical machine. Preventative maintenance meant early replacement of parts, which may still be healthy. And it might still break down between servicing if there was higher usage than what had been planned. Essentially, a lot of limitations. Then we had the clever air compressor, with a range of onboard sensors feeding a display panel on the unit. Preventative maintenance can now take the form of replacement of some parts depending on actual usage. Now we have the connected air compressor, which efficiently collects, orchestrates, and securely transmits real-time data into the cloud. This is combined with a virtual model or twin of the compressor. It's a digital model of the physical air compressor built based on historical measures of performance. This includes the expected service intervals, power consumption details, air output data, etc. And combining that with real-time data gathered by sensors on a specific machine. And that includes actual times of operation, vibration measures, even direct power consumption. Preventative maintenance now becomes predictive maintenance. It allows real-time adaptation of the compressor's capacity and power consumption in line with the actual air demand. Remote automation becomes possible, including the capability to send cloud-initiated commands down to the unit after validation with the digital model. In fact, it even opens up a whole new business model for companies like Sierra Wireless's client, Atlas Copco, selling air as a service, where they charge for air based on consumption and take on the role of running the air compressor most efficiently on behalf of the manufacturing line. This is achieved using the power of digital twins, and this is just as applicable to other machines or even the whole manufacturing line. So, a digital twin. It's a growing buzzword. It means a lot of things at the moment. It's been around for a long time, actually. It was invented by NASA. While the world held their collective breath during the disastrous Apollo 13 mission many years ago, engineers had a replica of the craft in Houston. This allowed them to test solutions and then pass on life-saving instructions to the crew. In today's world, we see digital twins as the next evolution of IoT. It's a digital model of a physical object, process, or whole system, bringing disparate data streams together, and is predominantly used to monitor, to interact, to forecast, and to simulate. Now, to dig deeper into why you would want a digital twin, there's essentially a wide range of benefits depending on the specific use case. In the case of the air compressor on the manufacturing line, I'll talk through 4. Firstly is extending asset life. This is achieved by predicting preventative maintenance based on actual compressor usage and understanding the surrounding environment. In this case, one of the recommended next best actions is to bring the service date forward for unit number 91. This is because sensors are detecting high levels of small particles in the external environment, which will degrade the filter on the unit faster, according to historic data. A second one is to be able to manage remotely. Operators and service technicians can see the compressor from the site's operations office, on the road, or even from head office. This helps from 2 perspectives. At an individual unit level, commands can be issued manually or automatically based on the historic and predictive data from all instances of that model. At a macro level, service teams can be rerouted to incidents while additional remote diagnosis is underway. Gives the benefit of improving efficiency through real-time adaptation of the compressor's capacity and power consumption in line with actual air demand, saving energy costs on the manufacturing line. And last but not least, it allows the opportunity to start testing changes without impact. What I mean by this is being able to test changes to the operations mode, tweaks and adjustments, and before running it on the real device, being able to test on the digital model to understand the impact on output, and also just as importantly, the impact on parts wear and tear. Now, to create something like this, it might sound like a strategic, multi-year project with large investment. It actually doesn't have to be that complex. In fact, we recommend getting the digital twin platform in place and focusing on one specific use case. This achieves a return on investment quickly. It proves the power of the digital twin within the business and sets the platform to begin to scale. So to achieve this, Arc Group and M2M Connectivity have evolved a value-based approach, which builds this for around $50,000 Australian. There are 4 key phases. The first is identifying the ecosystem. What is the measurable business outcome we wish to achieve? What is the data required? And what are the sensors required to gather it? This could be vibration, temperature, air quality, or even GPS sensors. And it often involves leveraging other existing external data sets. The second phase is connecting the ecosystem. This involves setting up the cloud-based digital twin data platform on mainstream providers like AWS or Azure. Then collecting the sensor data at the edge using devices like Sierra Wireless's Octave, which ensures efficient data collection, orchestration, and then secure transmission. And Benoit will talk in more depth about Octave shortly. Then it's taking that sensor data and then reliably transmitting it up to the cloud, which is where end-to-end connectivity shines. They can provide connectivity solutions even where the sun doesn't shine. The third phase is visualizing and impacting the ecosystem. This involves creating the most suitable interface to be able to see and interact with the digital twin. This can take a number of forms. In this case, it's the visual interfaces that you've seen so far. The fourth phase is definitely onto the more advanced stage, prediction and forecasting. It leverages the data gathered over time, which is then processed by the digital twin to begin proposing what might happen and what should be done about it. These can be notifications to the operators suggesting to make the changes, or integrated directly to make the event automatically trigger the change without human involvement. As you can see with these four phases, incorporating a digital twin into your manufacturing line can be straightforward. Back to you, Simon.
Thanks for your presentation. We've actually done a survey while you've been talking, and the results we got were, when considering the benefits of digital twins, what value proposition resonates most, and it looks like risk reduction and time savings were two of the key ones. From your perspective, are there universal, I mean, you've touched on them, but is there something, what do you think people are getting when somebody implements this solution? What do you think the results, the sort of immediate results will be, or that they will see?
Look, there's a whole lot really to consider. I mean, just take, for example, with the current state that we're in with the COVID and changing environments, where the ability to access remote locations, the ability to travel and be around in those places where you've got multiple sites operating, just that remote connection to be able to monitor, maintain, and make changes is, from a time-saving perspective, obviously critical. Risk reduction, the same situation as well. You can have less people on the floor and still be able to maintain a strong level of operation. And as it starts to, as you use the digital twin to not only monitor, but interact and make changes in that environment, that's obviously taking that automation to the next stage, which then will allow even more time savings and risk reduction in terms of volume of people.
Okay, great, thank you. We've had one question from the audience, and please keep those questions coming. It sort of relates to the fact that not all manufacturing companies have CIOs, CTOs, or tech teams to sort of manage these projects. So in that case, where would Art Group come in terms of, I guess, managing the project?
Certainly. So this is in part why we've worked with end-to-end connectivity to create this four-phase approach, where it is a lot more streamlined and structured model and a structured approach. And it takes that step back from having to go at a CIO's type level, make a 3-year strategic plan of going, yes, we're going to adopt digital twin. We think it's the future, and here's how we're going to do it. And we'll create working groups. We'll create, all of that can kind of put that aside, because the whole point here is to be able to have a small team operate and be able to start to build it out and prove it within your own business very quickly. Our involvement collectively, we're here to help along the whole journey, from going, yep, understanding the current state, whether there's no IoT devices, whether there's a whole lot of them, whether they're well connected into the cloud, whether they're less reliably connected. If you've got data lakes, data platform, all these little bits and pieces, that's part of the very first stage of what we'll do, is work to understand what they are and the current landscape, and then propose the steps forward. So you can really be looking at a fairly small team from a client perspective to be able to be involved in it.
Great. Thank you, James. It's exciting that manufacturing could be entering the space race. Okay, so next we're going to take a deep dive into the Sierra Wireless Octave all-in-one IoT solution. I'd like to invite Benoit to join the stage. Thanks, Benoit.
Thank you, Simon. So let's introduce Octave. So James mentioned that your digital twin project will go through several phases. Actually, the second phase is one of the most critical. If you want to build a live replica of your asset to get actionable insights, predict what could happen, and act without any delay on your physical assets. So this second step challenge is to connect your ecosystem. What does that mean exactly? Let's keep this example of an OEM operating air compressors in his factory. On the right part of this slide, you see that the OEM is using already a wide range of cloud applications on Salesforce, SAP, or Azure. His digital twins application is connected through Cloud API to the other systems to retrieve business or technical data related to this compressor. For example, when it has been purchased, when it has been installed, which maintenance plan is associated to it. But the OEM actually wants his digital twins to be a live replica of the physical compressor as well. For that, he needs to retrieve live data from the physical compressor and be able to send commands to the compressor in the field. But there is no simple API on the left side of this slide to connect the digital twins application from the cloud to the compressor in the field. So how do you do that? So you may think that it's complex to bridge the gap between the compressor, or actually your operating technology, OT in the field, and your IT, your information technologies in the cloud. Actually, you're right, it's complex, but fortunately, CRLS can help to fill the gap with an all-in-one device-to-cloud solution, including global connectivity on low-power cellular networks, device, and cloud API. So CRLS is well known as the leading IoT company, providing cellular IoT modules and devices for more than 25 years now. CRLS is a full MVNO as well, providing global connectivity services to millions of assets operated all around the world. Now integrating securely devices together with connectivity and cloud, we deliver this all-in-one IoT solution called Octave. So what is Octave in more detail? Octave is CRLS all-in-one solution for connecting industrial assets to the cloud. Octave lets OEMs and enterprise securely extract, orchestrate, and act on data from their equipments to their cloud infrastructure. So Octave is based on a distributed engines running at the edge on one side, on the left part of this slide, and on the cloud on the right part of the slide. With these engines running in JavaScript, IT developers can easily develop their own script to be executed either at the edge or in the cloud. So with this engine running at the edge, OEM developer can define which protocol to use to extract the data from the compressor. Modbus being very popular in this industry. Decide which data to process or store at the edge, when it shall be uploaded efficiently to the cloud, or which alerts to send directly to the cloud, actually. And on the other side, with the engine running in the cloud, OEM developer can define which data should be sent to which cloud applications and which commands need to be sent back from the cloud to the device, for example, to change the compressor mission profile in the field. All this securely from device to cloud or from cloud to device, from your digital replica to the compressor in the field, wherever it is in the world. So what is unique with Octave is that it gives you this capability to connect securely to your asset through a digital API from anywhere in the world. To achieve this, Octave includes devices, connectivity, and cloud connectors or API to various cloud vendors, such as AWS or Azure. On the left part of the slide, you can see some of the devices supporting Octave with different types of physical interfaces. The global connectivity is managed through multiple roaming agreements with mobile network operators around the world and CRLS SIM which is able to select the most appropriate cellular network at any place, anytime, based on radio information coming from the modules. So what we are going to see is that Octave allows you to focus on your data, accelerate your development, and scale your deployment. So let's focus first on the data. By providing this unique combination between devices, security, connectivity, data orchestration, and cloud API into a single platform, Octave allows you to focus on your data and on your use case. No need to worry about rebuilding all the layers of an IoT infrastructure. What this means is that when you first power on an Octave device, it connects your asset to your cloud in a secure and optimized fashion and becomes immediately available to run the use case you expected to deliver. Second, in the middle of the slide, Octave simplifies your development. So Octave significantly reduces the time to market, the main features being native support of standard interfaces, protocol as well to connect industrial assets, sensor, or even specific controllers, edge and cloud computing engines included as well, with an easy programming interface that use common JavaScript framework, and last but not least, cloud integration capabilities with WebSocket, REST API, or IoT Hub Connector, for example, in case of Azure. Third, Octave simplifies and de-risks your deployment. You can start quickly and scale fast using a unique platform from your early developments to your production deployments. With a unique platform, you can deploy and scale globally. You keep one single reference of device for your global deployments, and you can operate in more than 160 countries covered in 6 continents without having to handle the underlying cellular subscriptions. So you can easily deploy this device configuration that you wish to your whole fleet, wherever it is. So if you are a sales manager, you may want to know how much time your team of developers will spend to connect your digital twin. Actually, it will be pretty quick. It could take just a few hours with the 6 steps highlighted on this slide. So the first step, for sure, you will have to connect your IoT device to the asset. It can be a compressor in this case, or an industrial sensor. You will power the gateway. For sure, it needs power. Can retrieve the power as well from a battery. Then you can develop and test your use case using Octave all-in-one solution. And then you will see the data flowing easily from the device to the cloud on Octave, or to your targeted cloud and in your business app, once you have set up the cloud API to your business application. If you are satisfied, you just need to go to the 5th step, which is to save your configuration, make a blueprint of your configuration in order to be able to duplicate this blueprint to your digital, from your digital model to your physical asset and to other devices which are deployed in the field. So now, in other words, I would say we may want to go directly to the demo of Octave. You may be interested to see how easy it is to set up such a device, such IoT device connected to your asset. So let me switch to my screen, and I will go directly here to my company, actually, which is Octave Demo, and I've selected the device, which is my device, actually, which has been powered some time ago. So in this device, when I log on this device, you can see that it is actually connected. You can see the firmware release, which is running inside this device. and you will have access to some information such as serial number and so on. So when you receive this device, you have connected it to the equipment and to the compressor, and you have power it. It will be displayed like that. Now, what you want to do is to define the type of protocol that you want to use and configure the protocol that you want to use to extract the data from the physical compressor. So, for example, you will go to select a Modbus interface, and you want to specify the type of registers that you want to extract from the compressor into the IoT device. You will define as well the polling frequency. Here in this example, we pull the data from the compressor every 5 seconds. And so once you've done that, you save your configuration, your Modbus configuration. So back on the device level, if you have some issues connecting the device to your cloud or looking it online, you can simply go to the resources and check what is the network status or other parameters, such as here in this signal folder, you can see that the device is connected over LTE Cat-M, basically, so the low power LTE global network, which is pretty efficient to connect industrial assets to the cloud. You can see various type of information, such as the RSSI or key data related to the cells where the device is connected, in which country or on which mobile network operator. Okay, but normally you don't need to go to this type of resources. It's only for troubleshooting if you may need. Okay. Otherwise, so coming back to here, once you have defined the register that you want to extract, you may want to define the type of edge action that you want to process. So, for example, with such a JavaScript editor, you can define that you, based on the temperature, humidity, or dew point that you have extracted from the compressor, you may want to process that and compare the temperature to a specific threshold or the humidity to a specific threshold and take action, such as activating a relay or sending an alert to the cloud. Okay, so in this example, this is exactly what we do. We read the temperature value, and if this is above a threshold, we will turn a LED on the device, on the IoT device, to red. We will activate a relay to shut down the compressor, because if the temperature is too high, it's dangerous to continue to process and to compress the air, and we will raise the alert. Okay, so this is the simple JavaScript code that you can develop, and then you can go directly to the stream of data, which is going to the cloud, and you will be able to see the data flowing from the device to the cloud and reaching the cloud. So here, at periodic, every 30 seconds, going to the cloud with all the type of data. So here there is no alert, obviously. The humidity which has been measured is below the threshold, and the temperature which has been measured is below the threshold as well. Okay, so we don't send anything. Last point is to use a cloud connector. So if you want, for example, to send this data to another cloud, such as IoT Central, okay, so you will exit the device menu and you will enter the cloud menu here on the left part of this of the screen, and you may want to define a cloud actions, okay, to send the data, all this data to the cloud, but to a third-party cloud, which is IoT Central. Okay, so here, sending the data to IoT Central. How does that look? So basically, here I am on my IoT Central account with the dashboard coming from this device. Okay, so you can see a nice dashboard with all the curves of temperature and humidity of the day, actually. I'm in France, so it's just 10 hours before your time. So this is the actual humidity and temperature threshold. If I want to change, for example, the humidity threshold, then I can send a new command through this interface to change the threshold. So here, in that case, the temperature and humidity which are measured will become above this threshold. So I should have an alert which will be raised. So let's go first of all in the command stream of the device to see what has been received. So here I can see that the threshold has just been changed, actually. Humidity threshold set to 30, temperature threshold set to 20. So this is my last action right now. Okay, so going to the stream of data, now I can see that the alert has moved to 1 and the temperature is above the threshold. Okay, so that's in a few steps the demo of configuring an edge device to extract the data that you have defined from your compressor, from your industrial asset, how you want to process the data locally at the edge, which type of data or alerts you want to raise to the cloud, and on the other side, having the capability to send command from your cloud to your device. So I will stop sharing my screen on the demo right now, and back to this deck. You can understand that actually here you have the right representation of this IoT platform, mixing devices on the left, data orchestration engine, distributed at the edge and in the cloud in the middle, all this running on global cellular network, and capability to inject the data and to connect easily through cloud API to third-party clouds such as Azure in this demo, or AWS, or Google, or SAP, or other cloud. Okay, so this is for all these reasons, basically that Octave has been recently granted, recognized as a simple, scalable, and secure solution.
Benoit, I might just interrupt you. I've joined the stage. Just in the interest of time, I think that's maybe a good place to stop, and we can touch on some other points in our Q&A, particularly the unique selling points which you've just brought up. We've also had a couple of questions come through from the audience, which we'll try and address in the last 5 minutes of the webinar. James, if I ask you to come back, we'll run through some of the questions that have popped up in the webinar and make sure people go away with the answers that they need. I guess one thing that's been asked is, Benoit, in your presentation, you talked about hours to, I guess, get a system up and running, and then you give us a very in-depth presentation showing us the inner workings of the system. To me, that looks really complicated, but is hours realistic to actually get the system up and running, or is that what's the sort of stages of hours, weeks, and months in terms of implementation?
Yeah, so hours, I speak of hours, you just need basically, most of our customers had a first demo up and running with their physical asset in a few hours, so within a day. So the beauty of this effort for our customers is that they are able to bring this proof of concept to their board or their manager to prove the value of connecting the asset, of bringing data to their digital replica if they have already a digital replica of their asset, or simply getting real life data to their cloud. Okay, and this is accessible for any type of web developer. So you don't need to have embedded processing capability, embedded development skills to do that. So this is really the beauty of the solution. You can quickly poke and prove the value of this project. And then, as explained, you need a few days, of course, to go in the field to prove the robustness of the solution with a pilot. And here, usually, you need 2 to 3 weeks to execute the pilot properly before getting to the commercial phase, I would say, with deployment at scale.
Thanks, Benoit. And it's interesting you mentioned pilots, because a couple of people on the surveys that we've done have said that they are already running pilots, which is interesting. James, just to go back to one of your points, in one of the latest surveys, funding came up as, no surprise, one of the barriers to, I guess, adoption. 50K is something that you're sort of talking around in terms of, maybe an entry point for this type of solution. Do you think that's a realistic number?
Absolutely. And this is exactly why we've worked to create this framework of implementation and this methodology of putting these in place, because we recognize that digital, particularly if you're talking to the board and trying to get this buzzword of digital twin across the line, it can very quickly become okay, yeah, great. It sounds all these promises. Let's talk in 10 years' time when it's been proven everywhere else, I should say. The reality is there's a lot of proof out there of how it works and at large scale. But this is definitely at $50,000 the way we're recommending to approach, like Benoit was talking in that view from really behind the scenes, behind the curtains of the way that data comes through. It's leveraging great technologies like Octave, where it is handling and essentially, I suppose to one degree, almost commoditizing part of the process that makes it a lot more straightforward and the whole lot of things you've got to connect up to be a lot more straightforward. So yeah, absolutely. We understand that. That's why our approach is not about doing multi-million-dollar, multi-year, large-scale projects where you don't see return on investment till the end. It's about getting this up and running fast in place, actually using that as the demonstration and creating the business case for the larger scale and the larger rollout of it all.
Great, thank you. And just to finally, just before we run out of time, just to get your perspective on where is the Australian market right now. So if people are thinking about working with ARC and M2M on a digital twin project, it seems to me, I can see things online that have happened in Canada and the US, but is Australia quite a young market in terms of this technology? And I guess anybody who's taking this up, would they be sort of leading the pack in terms of for the manufacturing sector?
Look, it's certainly a young market in the sense that it's not every other manufacturing provider or every location has picked up digital twin or even full-scale IoT and automation. But it's not to say that it's new or unheard of in the market. Like just as you saw with the polls, groups of people that are on the call now, they're actively running pilots. So it's out there, the technology is there. And that wider scale adoption and that wider scale, I suppose, understanding in Australia that it has the power to make big changes, like big improvements in vast ways, like from manufacturing perspective in terms of time savings and risk and reliability. Definitely, it's sort of young in that regard.
Great. All right. Well, thanks, James, and thank you, Benoit, for your presentations. Thank you to everybody for attending today's webinar. I hope you've enjoyed hearing about the benefits of Sierra Wireless's Octave solution. And we believe that the ARC and M2M partnership around digital twins can deliver exceptional value and results for your business. And we hope this can be the start of a conversation which will help you on your digital twin journey. You can visit m2m connectivity.com.au for more information. But for now, thank you for your time.